back to Mrs. Achilles and Miss Paraso's video series. Today we're talking about the distance formula. So our question to start off with is how do we determine the length of the line segment, meaning the distance from one endpoint to the other?
Wait a second. Could we use the Pythagorean theorem?
How would we do that? It's
well,
just a line.
It looks like a line, but it kind of looks like a hypotenuse. Could we just draw two legs on it and connect them?
Miss Paraso, that sounds like a very smart idea. Let's do that. Do you mean like this?
Yeah, and then connect that. Yeah, just like that.
Okay, so I would use the Pythagorean theorem to find the length of the hypotenuse of this triangle.
Yeah, couldn't you just count the spaces at the bottom?
1, 2, 3, 4, 5, 6, 7.
And then count the spaces on the side. And look, now we could just do a squared plus b squared, and then we could get what c squared is.
Excellent. Let's do that. So we remember that the Pythagorean theorem is a squared plus b squared equals c squared. So a could be 7, b could be 4, and then we're solving for c. So 7 squared, 49, plus 4 squared, 16, equals c squared. 49 plus 16, 65, equals c squared. How do we undo the c squared?
I think we take the square root of 65.
That is the opposite of squaring a number. So now the square root of 65, get out your calculators.
I think it's going to be a little bit more than 8, since the square root of 64 is 8.
You're very smart. It is 8.1 if we round it. So 8.1 is the approximate length of our hypotenuse and the distance from this point to that point.
What should I round to when I'm doing this?
I think you should make a reasonable choice like we've talked about in class, maybe tenths or hundredths, whatever you feel is appropriate.
Okay, thank you.
All right, now let's talk about the actual distance formula. The distance formula is the square root of x2 minus x1, all of that squared, plus y2 minus y1 squared. Ms. Paraso, do you know where that comes from?
Well, it kind of looks a lot like a squared plus b squared equals c squared because I see two things squared added together, but then I'm kind of confused about the square root over the top.
Do you remember the last step we did before when we had 65 equals c squared?
Oh yeah, we took the square root of both sides, so instead of c, it's d for distance.
Yes. So we have the same line segment. We're going to plug it into this distance formula and see if we get the same answer. So we've got x1, y1, x2, y2, similar to when you label things for slope. Now, x2 minus x1 simply means the difference in the x values. So we have 9 minus 2, don't forget to square that, plus y2 minus y1, 6 minus 2, and don't forget to square that. The difference in the x values is really just this length that we had earlier on our triangle. The difference between the y values is this length.
Oh yeah, because last time we got 7 and we got 4, and you're gonna get 7 and 4. Cool.
So we know 7 squared is 49, 4 squared is 16, which equals, oops, that's a 49, which equals the square root of 65, which we already found to be
8.1.
approximately 8.1.
Oh, cool. That seems pretty easy.
So it looks like a long, complicated formula that we have to remember, but it's actually related to the Pythagorean theorem. Okay, so use the distance formula, or if it helps you, draw a right triangle on the coordinate plane to find the lengths of each side of this triangle that's already here. So AB, BC, AC.
Can you show me how to draw a triangle for one of them?
Absolutely. So you can go along your grid lines, and this would be the right triangle to find side length AB. And here is the hypotenuse.
Oh, I get it. So I can do that, or I can find the endpoints and use the formula.
Or you can find the coordinates of all the points. So for A, it's -7, 5. For B, we have -2, 1. And for for C, we have 3, 3. So you can either use the coordinates and plug them into the formula, or just go ahead and use the Pythagorean theorem by making a right triangle with each side length as your hypotenuse.
Ah, cool. Thank you.
Students, pause the video now and find each of these lengths. Welcome back. I hope you paused the video. Now, instead of solving them all out here on the board, I'm just going to go ahead and put the answers so that you can check your work. AB should come out to approximately 6.4. BC should come out to approximately 5.4. And AC should come out to approximately 10.2. For our last example, what do we do if we don't have it on the coordinate plane and we just have the coordinates? We basically do need to use the formula in this case. So we've got x1, y1, x2, y2, and we're going to plug them into our formula. So remember, to get the legs of the triangle, we have to find the difference in the x values, 7 minus -3, square all that, plus the difference in the y values, so -10 minus -4, and square all that, which is like a squared plus b squared. So 7 minus -3 is like 7 plus 3, so we have 10 squared, plus -10 minus -4 is like adding 4, so -10 plus 4 gives us -6 squared. 10 squared is 100. -6 squared, remember -6 times -6 is positive 36. And then we take the square root of 136.
Grab your calculators.
Grab your calculators, that's right. Should we estimate this first? What do we think it's going to come out to?
Well, let's see. 121 would be 11. And let's see, 12 times 12 would be 144, so maybe around 11.5.
It is actually 11.66, so we could say 11.7.
Oh, that's pretty close.
Pretty close, Miss Pariseau.
It's always a good idea to estimate, though, so we know if we did it correctly.
So we can think about the perfect squares that we know, and we know 11 squared is 121, 12 squared is 144, so we know our answer should be between 11 and 12. That concludes our video on the distance formula. Hope you enjoyed it.